Hello and welcome to my fifth combinational circuit video. This one will be on multiplexers. It's essentially it's another way that you can make decisions with logic gates as to which piece of logic you would like to operate under. That's a very broad definition, but you'll understand as we continue forward. So this MUX, we call it, that's the sort of abbreviation for multiplexer, is it can make decisions in between two different forms of logic here, or two different inputs, I guess. So basically what happens is we have this, this is called a selector, and basically what this does is that depending on what its value is, it will choose either to return this logic or this logic. So the D0 logic or the D1 logic. So say, for example, I wanted to, I guess we can just talk about the gates a little bit. So basically, say that I want to do this first one here. So since there's a wire connecting here which will return true when this is 1, and a wire connecting here which will return true when this is 0 because of the NOT gate, right? And so basically it's saying, that's how it determines which logic it chooses, which gate works, basically, because we're using an AND gate here. And so if say that I'm selecting the my S is equal to 0, then it's going to say, okay, well, we'll go for this one, and if this is 1, boom, then it returns 1 because of this OR gate here, and then it flows, and so. That should be obvious. But when it's 0, it's still 0. So it's saying whatever this is, that's what our output will be. And then say that I want to do, I want to use D1 instead. Well, I can just turn that to 1. Now it's saying, okay, well, let's use D1 because now this is returning true, and now whatever this is will be our output. And so that's kind of like essentially how the most elementary form of a MUX works. So now we can go to a 4x1 MUX. Basically, now we just have 4 different inputs that we can choose from. So this one you can only choose from 2, and this one has 4. And so for this one we need 2 selectors, and I'll kind of get into why. So these are all the 2 input MUXes that we had here. And to make a 4 input MUX, you have to use 3 2 input MUXes. And I'll show you how it works. So basically it's saying, okay, well, you can say this S acts as S0, except it works for both of them. So say that I just focus on the top one here. It'll work the exact same. So say that I have my S0 at 1. Well, that means that we're going to return whatever this one is doing. And then say that I have it at 0, we're going to return whatever this one is doing. Okay? And that's fine, but, well, what about this one down here? Well, that's what this selector chooses in between. So this connects to this MUX here, and it says, okay, well, when this is 0, choose the output from this result. And when this is 1, choose the output from this result. And so say that my S0 is a 0, and then my S1 is a 1, it's going to return this one right here. Because this is in the 0th slot, but we're also selecting it from the first slot from this is how do I describe it? It's like this is like one big MUX, one big 2 input MUX almost. Yeah, so you can imagine that these outputs are like these. Let's see, these inputs right here. So if you think about it like that, just consider these inputs, and then consider this my regular S, and then you have the exact same thing that we have here. All we're doing is allowing these 2 inputs to be determined by 2 other inputs first. And so that's how you make it 4 input mux, is that you just you sort of add a mux to the beginning, and you allow what these are to be determined by 2 different possible inputs. Yeah, and so with the, let's see here. And then with the 8 input mux, it's just another version of that. I mean, you just now those 2 inputs, whatever these 2 are, can be selected by. This can be selected by 2. This can be selected by 2. This can be selected by 2, and this can be selected by 2, which makes it 8. But we still only need. Oh yeah, so now we need 3 selectors. So for the selectors are 2 to the n. So if I have 8 say inputs, then I'm going to need 2 to the n is equal to 3 in that case. So I need 3 selector gates, or not gates, but three selectors, and so forth. So so this 4 input. You could like break this up, and this is 4 inputs, which is exactly like this one, and so we have, so this is S0. It's saying, okay, we're gonna take input from this queue here. Oh no, sorry, incorrect. This S2 is saying we're gonna take this queue here because this is selecting the 0 here. And then this S0 is saying, okay, we're going to take it from this group of 2 here. And this S1 is saying we're going to take it from this one here. So that will be my output. But say that I wanted to do S1 here. Well, so this S0 is saying, okay, we'll take it from the 0th column. So this is 0th column, this is first column, this is 0th column, this is first column. And then this is 0th column, and then this is first column of this 0th column. And so if it's S0, S1, then it's going to take it from the 0th, the first column inside of the 0th column, inside of the 0th meta column, you could say. So this will be, wait a minute. Did I get that backwards? Oh, okay. Hold on. Okay. So this one actually controls the meta column, and then yeah, this one controls the like second. So there's like the you could say the primary column, which is which one of these, and then the secondary column, which is which one of the groups of 2, and then the tertiary column, which is which one of like the entire section, which one of these multiplexers, I suppose you could say. So I take it back. Say that I wanted to do D1, well then it would have to be in the 0th column of the 0th like 4 mux, and then in the first slot. So it would be that. Can be pretty overwhelming, but really, it's just like a big tree. And once you understand how the tree works, you can just make more and more and more and more of them, and it doesn't really matter how many there are. And lastly, we have a 4-bit mux. All this is doing is it's just deciding in between 2 different inputs, except this time they're 4-bit inputs. But ultimately, it's different from an 8-bit input because it's not deciding in between like each of these individual bits. It's saying, okay, are we going to use this one or are we going to use this one? So really, we only need one selector. Versus this one, it's saying, are we going to use this one or 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 this one? This is just, are we going to use this one or this one? That's the difference. And so, so my SSS 0, well, it's going to do the 0th column. So that'll be my output. And say that I want to do my first column, well, it's going to be my first column. So there you go. I'm saying column, but I'm just saying like this is, that's just like one way to visualize it. This is just represented by 0, and this is represented by 1. I can go ahead and label it. You just call that 0, and you can just call that 1. Oh, I guess I gotta call that D0 and D1. They're arbitrary though. So yeah, and the way that works is that you just you have, let's see here. So you have a bunch of different 2 input muxes, and then they're controlled just by one selector here. So you plug all the most significant bits go up here. So most significant bit will be that one, and the most significant bit will be that one, which will plug into this one. And then so you could say so this is 2 to 0 1. So 2 to the 3 goes here, 2 to the 2 goes here, 2 to the 1 goes here, 2 to the 0 goes here. And same here. 2 to the 0 goes here, 2 to the 1 goes here, 2 to the 2 goes here, 2 to the 3 goes here. And so what that does is saying, okay, well, say that I have 0. Well, all of these are going into the 0th column, and all of these are using the same selector. So it's just saying all of the zeros are going to pass through, and then all of the zeros are then, and then all the outputs of these gates are connected to this singular output. So all of the zeros, which are these numbers here, go to the output. But say that I want to do 1s, and I was saying, well, all of the 1s are going to pass through, and these are all the 1s. So boom, and that's pretty much it. So, I mean, when selecting the number of when making these multiplexers, basically, it's important to know the number of inputs and outputs, because that'll tell you how many muxes that you're going to use in that circuit. So like, say that I have 8 inputs, well then I'm going to use an 8x1. But say that I have only 2 inputs, but they're 4 bits. Well then I'm going to use not one 8-bit mux, or sorry, one 8-input mux. I'm going to use 4 2-input muxes. So that'll change. It'll change not only the number of muxes that you use, but also the type of mux that you use. So you got to know like not only the number of inputs, but also how many bits those inputs are. And then same with output. I mean, I could have well, the number of input bits are actually going to be the same as the number of output bits every time. I'm sure you could come up with like something different, but typically this is how you're going to do it. For like a very basic, like, we want one input to represent the output. You know what I mean? So yeah, and that's pretty much it. So thanks for watching, and hope you learned. Thanks for checking out my website. Bye.